Okay, so what lesson 4 is going to be about is simplifying algebraic expressions involving radicals, but this one's going to be with like variables in it. So we're going to see a lot more of things like for example, you'll see a lot more, let's say like ax squared, right? So all the same kind of skills we've been dealing with, we just have to also deal with these variables. So, so first off, we're going to do simplifying. Simplifying algebraic expressions. And we're just going to go through a few examples with variables involved now too. So we've done, like I said, we've done ones like this, but all right, so let's say square root of x squared. So square root of x squared, do you guys remember, like, just, you're picturing this, right? This would be the same thing as, well, x times x is equal to x squared, right? So if you took the square root of x squared, what would that give you? Just x, right? It would be the same thing if I went like 3 times 3 is equal to 9. So the square root of 9 is equal to 3. You just get that out. Okay, so that's another way of thinking about that is if I've got the square root of something squared, they just cancel each other, right? So they just would end up with just x. Okay. So now, let's say we've got square root of x to the 4. We have kind of done this as a class because I did it with dash 1 and you guys are there. So, square root of x to the 4, what would that be? X to the 2. X to the 2. And the reason for that is because to get to x to the 4, right? So if I had x to the 4, that was made up of x squared times x squared. That's how you made x to the 4. So can you guys kind of see the pattern here? What if I had x to the 8? They took the square root of that. That would be x to the x to the 4. X to the 4. Because x to the 8 would be made up of x to the 4 times x to the 4. So remembering our exponent laws here, right? So you guys remember from last year, if you've got something to the power, like something with the exponent times the same thing with the exponent, what can you do with those exponents? You add the exponents, right? So that's the rule. So that's why x to the 4 times x to the 4 gives you x to the 8. And why if I take the square root of x to the 8, it gives me x to the 4. That, you guys agree with that one? So the pad, so you get good at this, right? You're going to be able to figure out, okay, what's the square root? What's the square root of x to the 24? What would the square root of x to 24 be? Yeah, x to 12. It's always going to be half when we take the square root of something. Okay. So on that note, so here, we'll call that was A, say this was B, this will be C. On that note, let's say we had the square root of x to the 3. And we want to simplify, which means we want to take out as much as we can, right? So I can't say it's equal to the square root of x to the 1.5, right? I can't just take half of 3. It has to be nice numbers. So what we're going to do, just like kind of what we've done before with just a number, is we're going to rewrite this as something I do know the square root of, right? So I know the square root of x squared. So I'm going to rewrite this as x squared times, and what would I have to multiply that to get to x to the 3? X to the Yeah, really just adding exponents.
Oh, yeah.
Yeah, so it's like x to the 1, right? Just x. Okay, so I split that up, and the whole reason I split that up is I know what the square root of x squared is. The square root of x squared is x. So that gets to come out as an x. So in the end, we just got x times the square root of, and then this x is still trapped in there. Okay. So let's do another one of those. So we'll go square root of x to the 7. I'm going to find the biggest perfect square that I can to split this up as. So I'm going to split it up as x to the what? 6. Because I know the square root of x to the 6. So x to the 6 times x. Or x to the 1, same thing. So x to the 6 gets to come out as a x to the 3. Good. X to the 3, and I've still got an x inside. Okay. E. Okay. Let's do a cube root. We'll say the cube root of x to the 4. All right, so cube roots now. Here, don't write this down. I'm just going to write this over here for a second. If I had the, so x to the 3, right? The cube root of x to the 3, what would that give you? What's that? X to the 1, right? It would give you x, just x, right? X, the cube and the cube root would cancel out, right? You think about it that way. Or you could think about it this way, that x to the 3 is made by going x times x times x, right? That's how we get x to the 3. So that's good. I can figure that one out. What about x to the, let's say, 6? What would that be made up of, right? What 3 things would multiply to give you x to the 6? 2, right? X to the 2, right? X squared times x squared times x squared would give you x to the 6. Right? And then, just to continue the pattern here, well, x to the 9. What 3 things would get multiplied x to the 9? 3. So x to the 3 times x to the 3 times x to the 3, right? So these are like the ones I know, right? I know the cube root of x to the 3. I know the cube root of x to the 6. I know the cube root of x to the 9, right? So those are the ones we're going to be trying to turn into what we do cube roots. Okay, all right, so if I'm doing this one, what do I want to split? What do I want to split x to the 4 up as? X to the 3, because I know that one, right? Times x. So this x to the 3, that gets to come out as a x to the 1. So that's just x times the cube root of x. You guys okay with it so far? All right, hopefully you guys have a bit more room than I do. I'm just going to keep going down here. Okay, so simplifying with 2 variables will be really similar. So we'll say 2. Simplifying with 2 variables. Okay, so we'll do A will be square root x to the 3, y to the 2. So it's square roots again, so we're just looking for like really even numbers. It's kind of, how this is going to work, right? So we'll split these up. X to the 3, I'm going to rewrite that as x to the x. I got to split up as two things. So it's going to be like x to something times x to something. Yeah, 2 and 1, right? Because I know the square root of x and 2. Any even number, I know the square root of. And then, am I going to split up the y squared? No, it's already good, right? I know the square root of y squared, so I can take that out. So I'm going to leave it like y squared. And then we're just going to take out everything that we can. So x squared gets to come out, and the y squared gets to come out. So that's going to be square root of x squared is just x. Square root of y squared is y. And then I've still got an x trapped under it. Okay. B. You know what? I'm going to go on to the cube root part of it. So we'll say cube root of x to the 11, y to the 6. Alright, so this x to the 11, I gotta find like numbers that add up to 11, right? Is what I'm really doing here. So I gotta split it up as x to the something times x to the something, right? 5 and 6, you think? It's cube root though, right? So remember those numbers with cube roots that like I know the cube root of x to the 3. I know the cube root of x to the 6. And I know the cube root of x to the 9. Right? Can you kind of see the pattern? Every like it goes up by 3. I know the cube root of all those things. So probably I'm going to choose this x to the 9 one, right? What is the cube root of x to the 9, by the way? X to the 3, right? So I know that one. So I'm going to split this up as x to the 9 times x to the 2. And then what about the y? I could change it. I already know the cube root of y to the 6, right? So that's good. That's actually perfect right now. So I'm going to leave that as y to the 6. Okay. And then we're just going to take out everything we can. So the x to the 9 gets to come out, and the y to the 6 gets to come out. All right, what does the x to the 9 come out as? Well, you already answered that one, right? That's x to the 3. And then y to the 6 comes out as y to the 2 times the cube root, and then x squared. Okay, that's it. That's kind of the main idea here. And then, yeah, I'll just throw a couple more examples at you. So, 3, I'm going to say simplify with coefficients. So now it's just putting the two things that we've already learned together, right? So if we had, let's say, here, I'm going to do a tougher one. We'll say a negative 7 y squared times the square root of 8 y to the 5. And by simplifying, I just mean we're going to take as much out of that guy as we can. We're going to take as much out, right? So just before we get going, what am I going to do with the stuff I take out, right? So when I take stuff out of here, I'm going to bring it down there, right? What happens with these numbers that are already there and the numbers that I pull out? What do I do with them? Yeah, you combine them, so you multiply them, right? So anything I bring out, I'm going to multiply by the numbers that are already out there. So far, these ones are just going to hang out for the minute. We're just going to keep writing them as we go. So I'll write negative 7y squared, square root. And then I just got to split up this 8, and I got to split up this y to the 5. So this 8, I'm going to split it up as what two numbers? So careful now though, because with coefficients, with actual numbers, I'm multiplying, right? I need to find two numbers that multiply to 8. 4 and 2, yeah. So I'm going to split it up as a 4 and a 2. So yeah, try not to get confused between exponents and numbers. They're different, right? Exponents, you're adding up to things, and the actual numbers or the coefficients, we're multiplying to them. Okay, so 4 and 2, because I know the square root of 4, right? Okay, and then the y, I'm going to split that up as y to the 4 times y, right? Because I know the square root of y to the 4. And then we're going to pull everything out that we can. So we've got negative 7y squared. And then, just so you can see them when they come out, I'm going to pull this 4 out, and I'm going to pull this y to the 4 out. So this 4 that I pulled out, what does that come out as when I take the square root of 4? 2, right? So this came out as a 2. What does this y to the 4 come out as? Y to the 2, right? Half, it'll always be half of the exponent. So y to the 2. And then I still have left in here a 2 and a y. And then the last thing is just actually combine, like actually multiply the numbers up front. So remember, when you're multiplying, it's just numbers times numbers, and then variable times variable. So negative 7 times 2 is negative 14. Y squared times y squared is y to the 4, right? You add exponents. Y to the 4. I still got left the square root of 2y. Okay, I'm going to do one more of those, just because we should. Alright, so let's go B. Say, that's actually easier. Let's do this one. 3x times the square root of 49, x to the 3. Alright. So again, I'm just going to, this coefficient up front, I'm just going to write this again. So this is just 3x, and I'm going to see what I can do in here. What am I going to split this 49 up as? 7 and 7? You're kind of onto something there, right? Does the fact that like 7 and 7 multiply this mean anything? This already is one of our perfect squares, right? Do I want to split it up? No, because it's perfect. And I get to take that out, right? This 49 is just going to get to leave. I don't need to split it up. So it's good to go. So start getting good at just recognizing those, right? So your perfect squares, you guys, like, as you're doing more and more questions, you're going to start to remember them. So when you see one of those, that's free game. You can take that out. Okay, so that gets to come out already. So then, I'll just leave that as 49 for now. X to the 3, I'm going to split that up as x squared times x. Okay, so the 49 gets to come out, and the x squared gets to come out. If you get confident with it, you could just actually multiply them, like in your head, at this step. But if not, write it all down again. So we go 3x times that 7 that I brought out. Right, because 49, square root of 49 is 7. And then x squared came out as an x. And then I still have an x trapped under the square root. Okay, and then last thing left to do is just actually multiply these guys. So 3 times 7, so we've got 21. And then x times x is x squared, then square root of x. All right. Next one, we're going to add and subtract. Okay, so really quickly here, if I had the square root of x plus 5 times the square root of x, and we'll push equal, put equals right below it. And I want to simplify this one. Do you guys remember that whole like terms thing, collecting like terms? Okay, so this is really like our like terms here is the square root of x is a lot like the square root of x. They're the same. They're like terms. So all I get to do is collect the numbers out front. So there's really a 1 sitting in front of that one. So it's 1 plus 5 is 6. And then you just write down whatever the like term was again. You've got 6 root x's, right? You had 1 root x plus 5 root x's. You now have 6 root x's. Okay, so getting a little bit tougher. Okay, so then we'll have 4 square root of x to the 4. Now let's go x to the 5. Minus 3 square root of no, that wouldn't work out. Here, sorry, I forgot to do that. Let's go 3 square root of 27x plus square root of 12x. Yeah, that'll work out there. All right, so the idea here is when I'm adding, I can't really do anything the way it is right now, right? Those aren't like terms. But maybe if I simplify these things, right? Take some stuff out of this one, take some stuff out of this one, I'll end up with like terms. That's kind of the idea there, right? So let's try and just simplify this one and then this one and then see if they'll turn into like terms. So I've got 3. What can I split 27 up as? What perfect square was in 27? 9. 9 and 3 times x. And what I kind of do here is just stay focused on this one, work all your way down, and then do this one, work your way down, and then add. So, okay, so I get to bring this 9 out as a 3. There's already a 3 out there, right? So that's 3 times the 3 I brought out, so that'll be 9. And then I still have left in here 3x. And then I'll go over to this one, right? So I'm going to split this up as 4 and 3 times x. And this 4 gets to come out as a 2. So I've got 2 times the square root of 3x. And I was adding these. So now they look good, right? Now I've got same, right? So 9 plus 2 is 11 times 3x. Okay. Now restrictions. Okay, so here's the idea. Is that if I have, let's say, the square root of x, right? Well, and I want to figure out what that is, right? So we'll say that's a. We're going to figure out what the square root of x is. So, just for a minute though, let's just take the square root of a couple numbers and see if we can figure this out. So if I said what's the square root of 4? You know, you would probably say 2. So good, we can take the square root of that, right? And then I said, okay, well, what's the square root of negative 4? This one doesn't have a great answer. The square root of a negative number, that's actually, we call it a non-permissible value. You're not allowed to take the square root of 4, or the square root of a negative number, I mean. Okay, and the reason why you're not, just to give you a little bit of reasoning here, if we kind of think of what square root is again, right? 2 times 2 was equal to 4, right? So 2 squared was equal to 4. And say if I went negative 2 times negative 2, negative times a negative, that's still 4, right? So we talked about this before, that if I take the square root of 4, it's actually the positive and the negative. You guys remember that? You actually get a positive number and a negative number, technically. So that makes sense. So square root of 4 equals 2, square root of 4 equals negative 2. But what could it even mean to say the square root of negative 4? That means you'd have to multiply some number by itself, and it would give you a negative number. That doesn't happen, right? That never happens. You can't take a positive number times a positive number and get a negative, and you can't take a negative number times a negative number and get a negative, right? You'll always get a positive. So the square root of a negative number, we say that's off limits. You can't do it. It doesn't make any sense, right? So back to A here. If I'm saying the square root of x, remember this is a variable. That means that we can put any number in there. Well, we can't put any number in there. I can't put negative numbers in there. So the mathy way of saying that is that it's the square root of x, and then follow me here. You say the square root of x, where, and that little comma that I wrote in math, that stands for the word where. So you'd say the square root of x. Here, let's write that down. Where x, now I'm just stating what x has to be. X has to be greater than or equal to 0. Does that make sense? Okay. You guys are okay with your greater than? It's like an alligator and it opens up to it wants to eat the bigger number. Yeah. Yeah. Okay, so it's bigger than 0. Okay. So now that makes sense. There's a couple of wrinkles here though. What if I had the square root of x squared? And I'm saying a restriction on that one. Well, I'm going to say here, well, you might say, well, x has to be greater than 0 again, right? But does it? Because let's just throw some numbers in here, right? So if I put 1 in, 1 squared is 1, and that's fine. That'll be the square root of 1, which will be a real number. If I put in negative 1, right? If I put in negative 1 squared, big class, right?
We missed a lot.
The 20-1s, I got them doing the lesson on their own, doing the lesson video.
Are you feeling better?
Better, still
Foggy, yeah.
Still foggy, but. So, negative 1 squared, what is negative 1 squared, by the way? What do you get if you square a negative number? Another way of writing this is negative 1 times negative 1. What would that be equal to? Positive 1, right? Negative times negative gives you a positive. So if I square this negative 1, I've still got a positive. And then I'm taking the square root of a positive, which is fine. That I shouldn't take this, that I shouldn't. Like up here? So you can't take the square root of a negative number, right? But what's happening here down here is I'm going to square negative 1 first, right? So if I kept on going with this, right? If I square negative 1 first, that'll be a positive, and then I'm good to go. Now I'm not taking the square root of a negative number anymore. So apparently I can put any number I like in for x, and it's always going to give me a positive number, right? So I can say for this one, the restrictions would just be x And then the way we say this, the way that we say x can be anything, is we say x, and then we use that symbol there. It's like x is a member of the real numbers. I showed you that in Math 10, right? Yeah, so x is a member of the real numbers. So is a member of. And then R stands for real numbers. That means it can be anything, doesn't matter. Yeah. Okay. So C. Let's do another one here. So C. What about, though, if I had the square root of x minus 7? So now, it's kind of like, it's a square root, right? I'm not squaring it or anything, so it's kind of like this one. Or sorry, it's kind of like this one, right? Where you think, okay, well, x has to be greater than 0. But it's not that x has to be greater than 0, right? It's whatever this ends up being has to be greater than 0. So the best way to do this is to figure out, okay, what would x have to be here to make it 0? Right? So what would x, so if you want to, you can write somewhere else, go x minus 7 is equal to 0. Like actually say it's equal to 0. So what would x have to be in that case? 7, right? 7 minus 7 would be 0. Right? So x has to be greater than or equal to not 0, but 7. Right? Because, and you can just try some numbers in there then too, right? So if x was, let's say, 6, right? If I put a 6 in there, that'd be 6 minus 7, that'd be negative 1. Can't have a negative. Right? So that's not good. So that's right. If x was 8, that'd be 8 minus 7, that'd be positive 1. So we're good. So that is definitely the right restriction that we put there. Okay. So now one more. So say D. So if we had square root of x to the 4 over x squared. Let's say something like that, right? So now the top part, right? If you've got x to the 4, that could be anything, right? That could be a negative number, right? Because that would be like, if I put negative 1, let's say, in there, that would be like negative 1 times negative 1 times negative 1 times negative 1. What would all those 4 negatives, would it be negative or positive in the end? It'd be positive, right? Because, yeah, if you just keep multiplying, those would be positive, those would be positive, yeah. So that's fine. So apparently because of the first one, I can have any real number. X can be any real number. So we're good there. The only little wrinkle here is the bottom. What number can you not divide by? What number will your calculator say error if you divide by? 0, right? You can't divide by 0. It doesn't make any sense to divide by 0, right? If I said I have 5 of something, and then I divide it into 0 groups, you know, that doesn't even like compute, right? That doesn't make sense. So we can't be 0. So what we'd say here then is just, so x can be any real number. So the way we'd write that with the restrictions would just be x cannot be 0. So we do a little equal sign with dash to it. Just can't be 0. Okay. Okay. Work for you guys enough. You guys deal with that. I was gonna do some more, but I think I've kind of like given you a lot there. So.
I was hoping that you could go through the